Muy buenos días a todos y bienvenidos a este simposio de diálisis sostenible. Pasaré un poco al inglés ya que algunos de nuestros ponentes son extranjeros. Bueno, good morning everybody and welcome to this thrilling symposium of sustainability in dialysis, where we can start. So as we should be aware by now, climate change is a fact, and in the specific context of nephrology, water and energy consumption, as well as waste generation, play a significant role in how we deal with the limited amount of resources. In this line, the commitment of the Spanish Society of Nephrology towards sustainability is clear, as our previous Congress achieved a zero net emission thanks to a compensation program. For all these reasons, the panel of experts we have here today will highlight different strategies that are being implemented towards a green and sustainable dialysis. So it's an honor for us to have here Frances Mortimer, Faisal Tarras, and Marta Arias. Our first speaker, Dr. Mortimer, studied medicine at Oxford University, trained in renal medicine, and worked for 5 years in the United Kingdom National Health Service. She's currently the medical director of the Center for Sustainable Healthcare, which is an institution dedicated to engaging healthcare professionals, patients, and a wider community to understand the connections between health and environmental and to reduce healthcare's resource footprint. So, Dr. Mortimer, it's a great pleasure to have you here with us. And sharing your experience. Welcome.
Thank you very much. It's a pleasure to be here. Can you hear me okay?
Not quite so good. So maybe some technical sounds from here, which is just a second.
Shall I try again?
That's much better now, maybe.
Yeah.
Go ahead, please.
Okay. So thank you very much for having me and thank you for that introduction. And yes, I work for the Center for Sustainable Healthcare, which is an organization based in the United Kingdom. And as you explained, it's an independent organization that works alongside the health services in the UK, but also everywhere to support sustainability. I have some slides to share with you to tell you a little bit about the work going on in sustainability and kidney care. So the context, as you've already mentioned, is that we are in a global planetary crisis, and it's to do with the way that we use the land, the way that we use water across the whole world, and also, of course, the emission of greenhouse gases contributing to climate change. And it's such a huge change to the globe that it's given its own name as the Anthropocene, as a new epoch. And the other thing that we all need to be really aware of is that we have a very, very urgent need to address climate change. We have only a very few years to change what's happening now. And that means that all of society needs to act. And we can't say that healthcare is too important. At the moment, we know that healthcare accounts for over 4% of global climate emissions. It's contributing to air pollution, which is making people ill. And it's also contributing to poor working conditions and other social injustice around the world. So in 2021, the UK Kidney Association partnered with my organisation, which is the Centre for Sustainable Healthcare, in the bottom right corner, and another organisation which in the middle, the Sustainable Healthcare Coalition, which is an organisation that helps to engage with industry about sustainability. And it founded this Sustainable Kidney Care Committee. And actually it was building on work that we had started back in 2009, 2010. We started a program that was called Green Nephrology. And we did quite a lot of early work at that time with the health service in the UK, and did some measuring of the environmental impact of kidney care and other work. But then that had been quiet for many years, and it's been restarted now. And because it's sitting inside the UK Kidney Association, it has a lot of the right people working on it and the right opportunity to put sustainability into education, to engage with industry around innovation, and also to put reporting standards for environmental impact into the normal ways that the kidney units in the UK report on clinical things. So it's a very good program that has the right things happening and it has the right stakeholders involved. So what is it that we actually need to change? Well, we need to understand what the environmental impacts of kidney care are made up of. There are lots of publications now. I'm just taking one slide that illustrates some of the data that we have. This is looking particularly at in-center hemodialysis. So from other studies, we know that dialysis dominates the carbon footprint of kidney care. It's very resource intensive. For a relatively small number of the patients, we're having the largest impact on the environment. The total is estimated about 3.7 tons of carbon dioxide equivalents per patient on hemodialysis per year. And that's about equivalent to about half of the total carbon footprint of an individual, an average individual in the UK. So it's like increasing that, if you attribute it to that patient, it's increasing their carbon footprint by a half. If you look at what makes up the carbon footprint, you can see that pharmaceuticals in dialysis, the dialysis fluids like the acid concentrate, bicarbonate, they are classed as pharmaceuticals. So they make up a large part. Patient travel, and also the plastic consumables for dialysis. And it's really about the manufacture, the supply chain emissions there. So you can see that we need to work with industry to understand what can be changed there. And then there is an environmental impact from the energy use. And there is also environmental impact from waste disposal. But it is really important to see that the greatest impact is from the making of the equipment rather than disposing it. So even if we were able to recycle everything, we would not be reducing the carbon footprint as much as we need to. Water is very important. It doesn't show up very well when you're counting the carbon footprint, but it is obviously a really important resource, which I know that the next speaker is going to talk about. So if you look at these things, you can see that we can take action in the way that we use the resources that we have. So I'm going to give you a couple of examples of things that can be done now practically with the equipment and the systems that we already have. But we also need to think bigger, really, because we should be designing, we should be asking the dialysis industry and the academic, the research sector to help with designing dialysis systems that use much, much less equipment, much less water, much less energy. And some of these things can be done, and there are already some technologies that could help. But with the equipment that we have right now, one practical change that not every kidney unit has made yet in the UK, but some of them have and have measured the impact, is to move to, instead of having separate plastic bottles of acid concentrate for dialysis, is to have the concentrate delivered from a lorry straight into a big tank, and then to supply this around the dialysis unit using pipes. And that saves actually about 1/3 of the amount of acid, because usually when people are changing the machine, prepare it for the next patient, they throw away about 1/3. They throw away the bottle of acid concentrate, and it still has 1/3 in it. But it also saves all of that plastic, and it saves a lot of staff time and lifting to load the acid bottles first into the storeroom and then into the dialysis unit. So there's some savings there. I think the next speaker is going to talk more about opportunities for water saving, but it is already money saving, even in the UK where we have lots of rain. It's still money saving to save water that is rejected by the reverse osmosis purification system. And instead of putting it down the drain, there are lots of other uses. This is an example of a unit that just introduced lots of smaller changes. So they organized the dialysis treatment times to reduce the number of cancelled ambulance bookings and to group patients to travel together if they're coming from the same area. They reduced food waste, which had, by offering patients more choice before they prepared the food. They reduced the linen use, which is also all the washing of the linen by working with patients to bring in their own warm blankets instead of using the ones from the hospital. And they also changed to a smaller bicarbonate cartridge. So those are all things that we can do that are really operational changes. And there are many others. You can do things like looking at your disinfection cycles and look at whether there are savings to be made there. There's many other changes we can make. But really, I would class all of these as operational changes. And if you step back a little, you can see that there's another category of changes that we can make, which is we can look at the actual care itself. We can look at opportunities to prevent kidney disease. We can look at ways to support patients to be an active partner in their care, and to reduce their need to access care, and be able to, for example, enable them to look at their own blood tests. So I have some examples here. This is a program in part of the UK where they're using the laboratories to screen people with diabetes and identify them early when their kidney function is declining. Different ways of giving patients more agency and ability to act to protect their own health. Many opportunities, certainly in the UK, I imagine in Spain as well, to reduce low-value appointments or low-value journeys and extra investigations, many different things that we can do. And then finally, as we get more definitive information about the carbon footprint of different treatment options, this could be about the mode of renal replacement therapy, but it could also be something smaller like whether it's better to give an injection or an oral version of different drugs. There's lots. Then we can make decisions that, as long as they preserve the quality of clinical care, then we can reduce the carbon footprint. So that's our goal really, and we call this sustainable value. We're looking to improve the outcomes, the health outcomes for patients and populations, to reduce inequalities, at the same time as improving environmental, social, and financial costs. So that should be our goal. I wanted to finish with just 3 slides about what's happening internationally and local to you that you could get involved with. So firstly, the S.E.N has launched the Green K initiative, where and this is the societies, the kidney care societies in many different countries all around the world collaborating to do some of the same work, but at an international level, which is really helpful, especially when engaging with industry, global industries. So then there's a new project which my organization is part of, which is funded by the EU Horizon funding, and it's due to start in 2024. And this is where we are going to have a 4-year program to support innovation, both in the technology and in the care and in the measurement of the environmental impact of kidney services across Europe, and produce guidance. So there are these partners. There are actually more partners than this, but I've shown 3. So the Dublin in Ireland are leading on some of the metrics and the project management, and my organization is helping with education and implementation, and then another organization helping with innovation and industry engagement. And then these are the 4 main clinical pilot sites where we're going to be working in the first couple of years before we work more in a broader, in more countries. And Madrid is one of those sites, so there will be some exciting work happening local to you. And finally, I would invite you all to join the Kidney Care Sustainability Network to share your work in this area and resources that you've found helpful. And it's also a good way to meet other people internationally who are working on sustainability in kidney care and ask questions and get help. So please do join us, and thank you for having me.
Thank you so much, Dr. Mortimer. I have to say, I joined the group, so I'm in there. That's tons and tons of information regarding sustainability. So I think it's a good idea for all of us. Shall we keep the questions to the end? So stay with us. Okay, don't leave. Okay, so our next speaker, Dr. Tarras, is a senior nephrologist based on the Center of Hemodialysis 2 of Mars in Casablanca. And for the last 20 years, his group has been deeply focused in the widespread of the awareness of environmental challenges among renal physicians, and also the management of dialysis water by means of water conservation and wastewater reuse, leading to the concept of zero liquid discharge, which I think it's a very interesting topic to be considered in especially water-stressed areas such as the Mediterranean basin. So, Dr. Tarras, thank you for being here with us.
Thank you very much for the invitation. Let me first thank the organizing committee for giving me the opportunity to be in here today. I was asked to cover the topic of towards zero liquid discharge in hemodialysis. Well, hemodialysis is faced with many challenges due to the huge resource, water, and energy consumption, carbon footprint, emission, and its consequent impact to the environment. Wastewater discharged by hemodialysis may have a significant impact on the environment due to its high salinity, turbidity, and chemical oxygen demand. The risk resulting from the discharge of this type of wastewater into aquatic ecosystem remain an important area of concern because of the potential ecotoxic effect of receiving water biota. The scarcity of water and energy and the legal constraint on the discharge of waste and wastewater are forcing hemodialysis facilities to change their approach to a more integrated concept of connecting the residual output in terms of wastewater, and energy loss to the input in terms of water and energy. In this concept, in this context, water resources management in general, and wastewater treatment, reuse, and valorization in particular are actually being an important worldwide challenges. Before I start, I have to declare that I have no disclosure in relation to this presentation. First of all, I would like to start by mentioning something that the nephrology community is well aware. I mean that the number of hemodialysis patients is increasing by about 6% a year, and actually estimated at 3.75 million worldwide. The number of patients in hemodialysis in my country, Morocco, with the 40 million inhabitants is about 36,000 patients. And I have been given an important information that the number of hemodialysis patients in Spain is about 26,000 patients. But what about water? Water is a vital aspect in hemodialysis, and during the procedure, huge volumes are used to prepare dialysate, to clean and reprocess machines and membranes, and water from the tap water prior to use passes through filters, softeners, and treated with RO. Wastage water in hemodialysis consists of wastage from the RO system, or reject water, which consists of 25% of total water wastage, and wastage from machines after treatment or spent dialysate, which consists of the remaining 75% of volume wastage. If we cross the number of patients realization with water consumption, we can find some shocking facts. I mean, the water consumption will approach 98 million cubic meters globally. In Spain, if we estimated that the 26,000 patients are in dialysis for 3 sessions per week, water consumption will approach 0.8 million cubic meters per year. The world demand for water is likely to surge in the next few decades. Rapidly growing population will drive increased consumption by people, agriculture, and industry. And according to the World Resources Institute, 33 countries will face extreme water shortage in 2040, and they are my country, Morocco, and Spain. Spain is prone to drought, and climate change has exacerbated the situation. Rising temperature, changing rainfall patterns have led to decreased water availability. In recent years, solution for wastewater disposal has been raised, among which a new technology called zero liquid discharge has gained interest worldwide. Zero liquid discharge is an expanding wastewater treatment technology in which hemodialysis wastewater is purified and recycled in order to avoid the discharge of water to the environment, but also to recover water and other resources. Hemodialysis wastewater is increasingly seen as valuable material, as a resource or as a raw material for value addition. There is a gold mine in our hemodialysis effluent, which still inordinately discarded to the seawater each year. Zero liquid discharge is an expanding water treatment technology that can extract these valuable resources from wastewater. This can include water, energy, and nutrient. Therefore, zero liquid discharge is always synonymous to circular economy and cost reduction, since the quantity of waste to be managed and the water consumed is significantly reduced. The first goal of zero liquid discharge is water reclamation. Zero liquid discharge is a treatment process that can convert hemodialysis wastewater to recycled water and solid waste, leaving in the end of the treatment cycle no liquid discharge. This can be achieved in hemodialysis through the reuse of the reject reverse osmosis water and the treatment of S.E.N dialysis. The first step towards zero liquid discharge is the reuse of reject RO water. In a typical system for using RO reject water, water generally flows to a storage tank and then pumped for redistribution. The system is regulated by flow switches, and excess water is diverted to drain if there is no demand. This is an algorithm to how to reuse the reject water. So first, before reusing it, it's better to check the salt level concentration in the water by the measuring of the TDS, or the electrical conductivity of this reject water. Water with conductivity below 1,500 microsiemens per centimeter could be safely used for any irrigation purpose, because too much salt can prohibit crop production. If irrigation is possible as reuse option, the sodicity of water must be checked through the measure of the sodium absorption ratio. A value below 9 is considered safe for most gardening. Water with the conductivity between 1,500 to 2,400 microsiemens per centimeter could be safely used for other purposes, such as flushing toilet or floor rinsing. In case where the salt content is much higher, a simple route could be to harvest other resources of water to dilute the salt progressively. Here are some possible options for use the reject RO water. The reject water can be reused for irrigation, for aquaponics, for toilet flushing, or for industry. The physicochemical composition of the reject water vary from an hemodialysis unit to another, but in general, it is dependent primarily on the chemical composition of the inlet water. Other parameters are for importance, such as the membrane type and the percentage of the recovery of the RO system. In a typical case, using a simple or a standard RO system with a recovery rate of 75%, the chemical composition and electrical conductivity of the reject water will be fourfold concentrated than the inlet water in terms of conductivity and chemical composition, and therefore, starting from any chemical composition of the inlet water, we can have an idea of the final composition of the reject water, and we can have an idea also of the possible reuse option for this. In this table, I report some studies carried out on hemodialysis reject water from different authors. As you can see, some reject water are suitable for irrigation, but others are not. To develop a reuse project, numerous parameters must be considered, such as the volume of the reject, its chemical composition, the location of the dialysis unit from the reuse site, but also the energy costs. Few studies have been reported in the literature concerning the cost evaluation of the reuse of the reject RO water, but in all reported studies, authors reported a huge economic profitability with short payback time. The second step towards zero liquid discharge is the recycling of spent dialysate. We have studied in one of our first study in 2008 the possibility of using the spent dialysate after treatment using membrane filtration technique like reverse osmosis or nanofiltration for landscaping our hospital gardens. We were motivated by the fact that this water consisted of 75% of the total wastage of water during an hemodialysis session. When comparing the physico-chemical composition and the bacteriological contamination of this water with the standards of the World Health Organization and the Food and Agriculture Organization of the United Nations regarding agricultural wastewater, we have found that except a high salinity level, other chemical parameters, the bacteriological contamination and level of organic matter were within the limit of both standards. We have found that treating this water to be reused in agriculture as agricultural wastewater was 20 to 30% cheaper, and the energy demand and carbon footprint lower than for the seawater desalination. But as you may know, there are several countries in Africa, in Middle East, in United States, or even in Europe, in France or in Spain, who desalinated their seawater to use as drinking water or for agriculture. The second goal of zero liquid discharge is to recover energy from the wastewater. It is possible to recover heat energy from our hemodialysis wastewater. Hemodialysis wastewater maintain a considerable energy quantity with this discharge to the seawater with a temperature ranging from 20 to 25 C. It is estimated that up to 1,600 gigawatt-hour per year of thermal energy is lost in seawater in all dialysis units all over the world. This quantity is enough to heat approximately 140,000 homes with an annual fuel cost saving of 180 million euros if recovered using techniques like heat exchangers. We can also recover, if possible, hydroelectric energy from wastewater. For this, we have equipped our double RO system with hydroturbines to recover electrical energy driven from the mechanical energy of the flux of RO reject water that live in the RO system. We were able to generate much energy to light on some spaces in our units or to power on some TV screens on a daily basis. But more interesting, we were able to participate to cut down our CO2 emission. We can also have as a goal for zero liquid discharge to recover nutrient and biofertilizer from the wastewater. Like human urine, hemodialysis wastewater maintains a good amount of nitrogen and phosphorus that, aside being removed, can be recovered through physicochemical techniques such as crystallization of styrivate. Styrivate has been shown to be profitable when used in agriculture. We have been able to demonstrate that in hemodialysis facilities with 20 chairs and working in 2 shifts per day had the possibility to generate 2.4 kilograms of styrivate per working day with profit and the possibility to fertilize 5 hectares of arable land per year. Zero liquid discharge can help us also reduce our carbon footprint. We can decarbonize in our hemodialysis unit through the reuse and the treatment of hemodialysis wastewater. As you may know, the carbon footprint of hemodialysis and its effluent is high. The carbon, treating wastewater can cut the carbon emission by about 1/3. We can also decarbonize through the recovery of thermal energy from our wastewater. Recovering this energy could result in a saving of approximately 0.6 kilogram of carbon dioxide emission per each kilowatt hour of recovered thermal energy. We can also decarbonize through recovery of nutrient and biofertilizer. The use of saliva as a fertilizer could reduce the carbon dioxide emission by approximately 0.35 kilogram of carbon dioxide emission per each kilogram of produced saliva. In summarizing, due to the scarcity of global water resources and ever-increasing need to protect the environment, zero liquid discharge appear more and more important. In Morocco, my country, we are working to develop a kind of sustainable dialysis with the ability to integrate the circular economy model by transforming all waste into raw materials in order to reduce the environmental impact of the hemodialysis treatment. Thank you very much for your attention.
Thank you very much for sharing all your huge experience regarding water. And finally, our last speaker, Dr. Arias, is a nephrologist from Hospital Clinic, and she is the Quality Control Coordinator of the dialysis service. She is actively working in bringing sustainable actions to a third-level hospital, and she's also a board member of the in-center hemodialysis group of the Spanish Society of Nephrology. Thank you very much for coming. Please, the floor is yours.
Muchas gracias a todos, sobre todo a la Sociedad Española de Nefrología por haber aceptado esta propuesta desde el grupo de hemodiálisis en centro, porque realmente consideramos este tema muy, muy, muy relevante. Yo creo que habéis visto todos estos datos que han presentado tanto la doctora Mortimer como el doctor como Faisal, y la cuestión es que a pesar de toda la conciencia que tenemos de sostenibilidad, ¿quién no va caminando por la calle y ve signos y signos de ser más ecológico, ser más sostenible? De hecho, ahora hay lo que le llaman ecoansiedad. Los jóvenes están sufriendo de ecoansiedad porque quieren reciclar tanto y tanto que le produce muchísima ansiedad. Bueno, pues a pesar de esto, estos son las cifras que tenemos en el registro, como veis, de earth.org a nivel nacional. En España estamos en el Global Ranking, situados en el 12º puesto, y sí que somos, en lo que son energías renovables, no estamos tan mal, veis que estamos en el 7º puesto, pero a nivel de políticas de sostenibilidad, la verdad que yo creo que no lo estamos haciendo del todo bien. Y como ha dicho Faisal, si no cambiamos urgentemente nuestras políticas a nivel climático, la temperatura incrementará 2,2 grados en el año 2040. No estamos tan lejos de esto, ¿eh? Entonces, 3 pinceladas de lo que es el concepto de sostenibilidad. Yo vengo a hablar de mi libro, de Diálisis, pero creo que es necesario entender que la sostenibilidad no solo se habla a nivel medioambiental, sino que existe la sostenibilidad de las personas y la sostenibilidad económica. Aquí se han dado muchos datos económicos, yo no entraré ahí, pero creo que también es importante cuidar el entorno, las personas con las que estamos trabajando a nivel de conciliación, a nivel de relevo generacional, como veis, a nivel de retención de talento, para también conseguir otros tipos de objetivos en sostenibilidad medioambiental. ¿Y qué es lo que se está haciendo? Yo hablaré a nivel local, lo que conozco, y os daré datos propios de nuestro hospital, de lo que está haciendo a nivel de sostenibilidad de las personas. Para considerar un hospital saludable, sabéis que hay certificaciones también al respecto, se pueden hacer mucho tipo de iniciativas, veis a nivel de dar consejos específicos del sueño, actividad física, alimentación, bienestar emocional y social, perdón, que está todo en catalán, pero la página web nuestra está así, pero esto lo que pretende a todos los trabajadores del hospital es darle consejos hacia un hospital mucho más sostenible y saludable. Y yándonos un poquito más ya hacia lo que es la diálisis, los números de los pacientes que estamos dializando actualmente son abrumadores y esto no va a hacer más que crecer. Nuestra población está envejeciendo y cada vez entran con una mayor edad. Y estos números, si no hacemos algo al respecto, son absolutamente insostenibles a nivel medioambiental. Entonces vamos a situarnos para que veáis los números. Estos son municipios de Barcelona. Aquí os he señalado en verde donde vive mi compañero Miquel. Para que os hagáis una idea, ahí viven 27.000 habitantes y el promedio de consumo de residuos por habitante y por día es 1,17. Estos son datos del año 2022. Vamos a ver lo que ocurre en mi hospital. Esto es lo que consume por día un paciente en el hospital clínico. Consumo de residuos, 11 kilos. Vamos a ver lo que pasa en nuestro centro de diálisis, 2,1 kilos por día. No estamos mal, ¿eh? El doble de lo que consume una persona en cualquier municipio de Barcelona por día. Vamos a hablar un poquito de los tipos de residuos. Esto parece un poco básico, pero aquí es donde tenemos que trabajar, en disminuir la gestión de residuos, sobre todo de grupo 3 y grupo 4, e intentar gestionarlos lo mejor posible. Grupo 1, grupo 2, aquellos sin riesgo, son los que todos estamos un poquito más acostumbrados, los del grupo 1, los que aprendemos a reciclar adecuadamente, papel, plástico, los que veis aquí en los iconos de la izquierda, los del grupo 2, relacionados con la actividad sanitaria, aquí empezamos a tener problemas. Y grupo 3, grupo 4, aquellos que tienen algún tipo de riesgo infeccioso, riesgo específico y que son los que tenemos que aprender a gestionar bien, porque lo estamos haciendo tremendamente mal. ¿Y qué pasa con todos estos residuos? Que depende de dónde los lancemos, irán a un sitio o irán a otro. Y esto implicará un coste económico. Los del grupo 1 o 2 sabéis que van al vertedero. Algunos de estos se pueden recuperar, lo que se llama valorizarlos. Grupo 3, estos tremendamente caros, se esterilizan. Grupo 4, se incineran y alguno de ellos también se recupera. Grupo 4, para que estemos familiarizados, todos aquellos que lleven aquellos símbolos que veis al final a la derecha de la diapositiva. Nosotros hacemos cursos de capacitación de enfermería en diálisis y nuestro jefe de residuos detectó que tenían desconocimiento en cómo gestionar algunos tipos de residuos. Sobre todo tiraban las jeringas con las agujas al contenedor de agujas. Esto que hace que ese contenedor se llene y cueste mucho más la gestión de estos residuos que mal tirados están a este contenedor que es del grupo 3. Las líneas de diálisis, lo que hablaremos, si las vaciamos bien, podemos considerarlos un grupo 2, excepto en los pacientes virus B. Y todos aquellos drenajes y catéteres, si no tienen puntas y están vacíos, también podrían ir, como veis aquí, a la bolsa gris, grupo 2. Estos datos ya nos los han presentado. El sector sanitario de por sí es responsable del 4,4% de las emisiones globales netas. Y dentro de esto, nefrología con la diálisis es un gran culpable. ¿Qué nos pasa en el sector sanitario? Que no estamos regularizados. O sea, nadie nos obliga a disminuir las emisiones de CO2. Lo único que nos hacen es subir cada vez más los impuestos medioambientales, lo que pesa la tonelada de residuos que generamos, alrededor del 10-15% anual en mi hospital. Tenemos publicados en la revista de nefrología unidades que están certificadas por la norma ISO 4001 en gestión medioambiental, pero tampoco es obligatoria. Y fijaros, de 210 hospitales, solo el 25% de los centros hospitalarios, cuando se publicó esto, que fue en el 2015, estaban certificados. Y esta es la única forma, si nos certificamos, de tener indicadores. Y estamos muy lejos, muy lejos, os digo, de lo que están haciendo a nivel, como habéis visto, europeo, en Marruecos con el doctor Faisal, y nos tenemos que subir a este carro. En las guías publicadas del 2020 únicamente hay una frase relacionada con sostenibilidad. Así que creo que desde la sociedad deberíamos intentar redactar algún tipo de documento que nos ayudara a esta mejor gestión de residuos, gestión del agua, gestión de residuos y intentar ser algo más sostenibles. Vamos a ver un poco, según cómo reciclemos, fijaros en este artículo que me pareció muy interesante, según lo perezosos que seamos, lo que esto afecta a nivel de cantidad de residuos y a nivel de coste económico. Tenemos a la izquierda los que reciclan mejor. Fijaros en las cifras con los de la derecha, que son los que reciclan, vamos a decir lo que son un poquitín más perezosos, los que reciclan peor y el coste económico que esto supone. Es un artículo muy interesante porque nos dice lo que sí que puede ser reciclable y ahí en imágenes lo tenéis todo. Entonces, ¿qué hacemos? O sea, no es fácil, ¿eh? Yo no voy a venir aquí a vender que esto de reciclar es fácil. Todo depende si ya tú vas a crear un centro de diálisis nuevo, como ocurrió en Tarrasa, que tiene unos centros de referencia a nivel de sostenibilidad, ¿no? Y tienen, como veis aquí, todo tipo de infraestructura, paneles solares, pellets como combustible para el sistema de calefacción, suelo radiante para la climatización, que es algo de lo que consume más CO2, una compactadora de residuos que hace que ocupen menos, un aljibe de 91.000 litros que luego utilizan ese agua, un poco como lo que ha contado el doctor Faisal, para poder regar y utilizarlo para aguas grises y una planta de aguas automatizada. Pero ¿qué pasa? Que eso no es lo normal, empezar desde ahí. Casi todos tenemos nuestro centro de diálisis y de ahí a ver cómo podemos mejorar. Entonces, yo lo que os diría es que empezáramos por calcular nuestros indicadores, que es en lo que nos está ayudando nuestro jefe de residuos. Aquí, como veis, son los datos del 2002 de consumo a nivel banal de cartón y de plástico. Y gracias a esto, año a año, desde el 2018, podemos ver un poco qué es lo que está ocurriendo. A nivel de residuos de grupo 2, como veis aquí, hemos aumentado. ¿Por qué? Porque hemos cambiado el formato de las cubas. Probablemente es lo que hemos analizado con él. Antes nosotros tenemos concentrado centralizado, que antes estaba en cubas de plástico y ahora ha pasado a un formato de cartón y otro tipo de plástico. Estamos gestionando nosotros los residuos, no Fresenius como es en este caso. Con lo cual han aumentado los de tipo 2 por el cartón y los de tipo 3, los de plástico algo más. Pero sin embargo hemos disminuido porque hemos hecho formación con enfermería en los residuos tipo 3, en el contenedor de agujas, porque ya no nos tiran lo que es la parte del plástico. ¿Y qué ha ocurrido con el agua? Desde que hemos cambiado a este concentrado centralizado y tenemos estas plantas de agua con un rendimiento cercano casi todo el año al 75%, hemos conseguido reducir el consumo de agua, mantenido el consumo a nivel eléctrico, ha aumentado ligeramente, pero sin embargo los residuos de grupo 1 o 2 sí que los hemos aumentado, pero hemos disminuido los del grupo 3. Aquí no me pararé mucho porque esto lo presenté ayer en un póster, pero también al automatizar la planta de aguas, lo que hemos ahorrado en costes y somos algo más sostenibles es el desplazamiento del técnico de diálisis al centro para hacer toda esta recogida manual de datos. ¿Y qué hemos conseguido con enfermería? Hemos conseguido que hagan el vaciado completo de las líneas de diálisis para que, en vez de situarlas en un grupo 3, las sitúen en un grupo 2. Ya no tiramos lo que es la parte de medicamentos, como digo, a estas cubas de las agujas, sino que se reciclan en estos contenedores rojos aparte y se intentan reusar. Separamos, veis, el empaquetamiento de las líneas en papel y en plástico y se ha modificado el concentrado ácido hacia una bolsa que permite reciclarla también como un grupo 2. Esto es una idea que me dio Frances Mortimer. Está bien tener en las unidades ideales los que se llama Kidney Unit Sustainability Champion, a una persona que esté absolutamente entregada a esto de la sostenibilidad ¿Y qué hace? Pues también lidera, junto con otras compañeras, que se intente reciclar lo mejor posible. Las analíticas no las trasplantamos en bolsas de plástico, las transportamos en papel. Dentro del hospital también se ha cambiado todo lo que son vasos, a papel, y hemos reducido el número, estamos intentando reducir el número de papeleras por puesto de trabajo. Esto es una iniciativa del hospital, cierra la luz, utiliza óptimamente el aire acondicionado y aquí es un poco donde yo creo que podemos trabajar. Os he hablado del manejo de lo que son la gestión de residuos, trabajar en la prescripción de nuestra pauta de diálisis. Ayer nos lo comentó la doctora Guillermina Barril. Tenemos que intentar reducir este flujo de diálisis. Ya veníamos de épocas de 800, se bajó a 500. Intentemos bajar a 400. Nosotros tenemos muy buenos resultados desde hace muchos años y de ahí trabajar, evidentemente, desde las unidades de ERCA en la prevención en la nefroprotección para retrasar la entrada en diálisis y, evidentemente, hacer formación a este sentido. Y siguiendo un poco lo que escribió George Sand, que es esta novelista francesa del siglo XIX, tenemos que empezar a poner ciertos límites. Voy a aprovechar que está aquí el doctor Vera, que es nuestro coordinador de diálisis domiciliarias, para lanzar. Yo sé que estamos intentando impulsarlos, pero desde la sociedad, y se está haciendo un gran trabajo desde la sociedad, pero hay que continuar. Este es el futuro, trabajar en las diálisis domiciliarias. No hay mucho comparando todas las técnicas. He encontrado este artículo italiano de esta provincia preciosa que se llama Belluno, que debido a que solo tienen 4 centros de diálisis, han impulsado estas técnicas, han comparado HD, paciente moviéndose en coche, en minibús, en ambulancia, con terapia domiciliaria no asistida y asistida, y los costes son radicalmente diferentes, sobre todo a expensas del transporte. Lo que es más sostenible es una HDD no asistida, porque la persona que vaya a asistirle a casa también consume, pero con grandes diferencias frente al HD. Aprovecho esta foto que me pasó un compañero y os pregunto de dónde creéis que es o dónde está hecha. Yo pensaba que estaba hecha en Barcelona, a la orilla del mar. Está hecha en Andorra. ¿Vale? Que sepáis que todo lo que tiramos a la alcantarilla al final acaba en el mar. Yo no digo que hagamos esto, pero simplemente que empecemos a pensar un poquito más cómo gestionamos todos los residuos. Muchísimas gracias.
Muchas gracias, Marta, por toda tu experiencia. Some questions from the audience? Yes? This microphone there? Yeah, okay.
Le felicito por las excelentes charlas y lo impactante e inquietante. Ya me ha empezado esa ansiedad que dices tú, Marta. Ansiedad de lo ecológico. Bueno, bien. Una pregunta para ti, que es, dentro de las normas ISO que forman parte de muchas acciones de los hospitales, en la norma creo que es la 2014. No sé, la
14.001.
14.001, exactamente. ¿Está incluido un apartado específico para diálisis? Esa es lo que te iba a preguntar.
Gestión de residuos, un apartado específico para diálisis. Bueno, está hecha para centros. Es gestión de residuos.
Vale, pero,
ahora mismo tendría que mirar si hay un apartado específico.
Lo digo porque la dificultad que tenemos es que en las unidades, como a la que tú haces referencia, pues a veces tenéis más margen para poder, no solo esas normas, sino generar un poco de acciones como las que has dicho. Y claro, es una fórmula que si no está incorporada en la norma, a lo mejor, ¿qué opinas de ponerlas como el acuerdo de gestión de los servicios, ¿no? Como una cuota de porcentaje
porcentaje de cumplimiento de indicadores de gestión de residuos.
¿Se ha valorado esto o tenéis idea de que se podría hacer una fórmula?
Yo, a ver, esto, claro, es muy dependiente de la política de cada servicio, ¿no? Y de cada hospital y de lo que quiera impulsar estas políticas de sostenibilidad. Nosotros ahora mismo sí que tenemos una línea muy fuerte de sostenibilidad en el hospital y se están impulsando todos estos indicadores. Si se le pone como objetivo al jefe de servicio y este se lo transmite al gerente del hospital, evidentemente eso es lo que tendremos ganado. Pero ya te digo, en el sector sanitario, por desgracia, es muy complicado porque nadie nos obliga a llevar estas normas ISO. Ahora, si tenéis coordinadores de calidad que también os puedan dar support, entonces tendréis mucho terreno ganado.
Perfecto. Y la otra pregunta es for Dr. Taras. I would like to thank you because after reading your paper in 2008 in the American Journal of Kidney Disease, we contact with a dialysis center in a clinic where they were able to develop some kind of system like you described there, and they use the water eliminated for the toilet flushing. And it's the only center that I know in Spain they use the water for that. And I just want to thank you because I read your articles, I follow your actions, and I live in the Tenerife, Canary Islands. We have the same problem with water like you. And I take all the message that you gave us to try to incorporate it to our unit. Thank you very much.
Thank you. It's my pleasure.
Okay, any other questions? No? I just want to ask you, Dr. Mortimer, I think it's quite awkward question, that all these changes have to be done, but we need to do it hand by hand with the industry. How can we convince the providers to go from greenwashing to green working? What's your experience?
It's mixed because many of the providers are more engaged with sustainability than some of the clinical centers. So the suppliers, I mean, are often more engaged, but at the same time, they need to have belief that if they do innovate and produce a sustainable product, that we would buy it. And we need to come together as an international community to agree the standards that we want for sustainable products, to ask industry to innovate, and then to agree collectively that we would adopt those technologies. I think, I think we need to work in partnership as well. So I think there's quite a big opportunity to bring together what is the what are the challenges that we face and how can we solve them together. But then we also need to be mindful of their business model, which is that at the moment, many of those companies are making money from selling large quantities of single-use equipment. And we need to make it clear that that's not what we're going to be buying in the future, and that we would like to work with them on different service models. Some of the things that changes that can be made now, I mean, including the delivery of dialysis fluid centrally into a big tank, is actually more economical for the company as well as for the buyer. So, I think there are some immediate opportunities. In the Horizon project that I mentioned, there is going to be a work program around looking at different technologies that are either already almost being used in a few places but could be used in more places, or that are in development and aren't used yet, and to look at working together with clinical sites to see what can be implemented and what can be improved to make it easier to implement.
Yeah, absolutely agree. Thank you. And just one little question for you, Dr. Taras, that we have spoken about the wastewater. Is there any possible use for it as watering crops and fields? But how about dense populated areas? How can we do that in the cities? Is there any possibility?
Yes, there is a possibility to do that. Just we have just to check the chemical composition of this wastewater. So I talk about the reject water, but for the spent dialysate, we can have to treat it first before use it. So There is one experience in Australia. They collect water and they use it for irrigation of their golfs and for their gardens, municipal gardens. So it is possible to do that, of course.
That's why, yeah.
It depends just on the chemical composition of this water.
Our salinity.
Yes, and actually there are some authors in Malaysia or in Thailand who use the reject water for aquaponics. So the aquaponics method for growing fish and growing plants at the same time. So in their units they are growing fish like tilapia and many other plants. And also there is one smart recent possibility to reuse the reject water and also the spendalizate because this water is water with high fluoride content. So we are actually in Morocco trying to discuss with factories who produce the cement bricks because the free chloride is water is a good water. When it is used, they provide a high durability to the cement bricks. So this is a good water, and this is a possibility to help these manufacturers to recycle this, to reuse this water, and also for us to be more greener.
Yeah, absolutely agree. Thank you very much. And some questions for you, Marta. May I ask you something?
Yeah.
Okay, so what do you think that, how can we convince scientific societies to bring this sustainability? Shall we create some groups? Each group must have their sustainability coordinator, or what do you think?
Me encanta que estén la expresidenta y el presidente aquí. Y no sé qué pensarán al respecto. Claro, tenemos muchos grupos de trabajo. Entonces, yo creo, sinceramente, que habría que coger aquellos grupos de trabajo que están directamente más implicados con la sostenibilidad. Tenemos el grupo de terapias domiciliarias, el de hemodiálisis en centro, el de enfermedad renal crónica. Esos grupos que sí que pueden aportar más hacia una mejora en la sostenibilidad renal, que crearan su mini grupo de trabajo en sostenibilidad, que tuvieran su coordinador. Es muy importante tener una persona que coordine esto. Ay, qué bien que viene nuestro nuevo presidente aquí a decir gracias. Y que haya una persona que lidere. Es fundamental en cada grupo de trabajo, porque si no, esas iniciativas no saldrán. No sé qué piensas.
Buenos días. Ayer una de las cosas que hice fue transmitir lo que son las líneas estratégicas de la nueva Junta Directiva, que van a ser continuistas con la magnífica presidencia de Patricia, pero ha añadido una nueva pata, que es la lucha contra el cambio climático. Como bien decíais, la nefrología es la especialidad médica que más contribuye al cambio climático y está en nuestro tejado el empezar a hacer cosas. La sociedad nos lo va a pedir y lo debemos de hacer. Soy el representante de la S.E.N, esto ya porque estaba en la Junta Directiva con Patricia, en el foro de alianzas médicas contra el cambio climático. Hemos tenido ya la primera reunión en el Parlamento Europeo, en la sede de Madrid, y se van a establecer ya líneas de actuación en las cuales la nefrología va a tener un papel relevante. Así que entre todos no nos va a quedar más remedio. Ya no es que queramos hacerlo o no, ya no es que esté de moda, no es que tengamos ansiedad por reciclar, sino que no nos va a dar más remedio que hacerlo. Y la S.E.N, los nefrólogos españoles, vamos a tener que hacerlo. Gracias.
Muchísimas gracias.
Esperemos que sí. Well, so thank you very much. Thanks, Dr. Mortimer, Dr. Tarras, Dr. Arias. Thank you very much for coming and share your experiences to what I think that highlight there's still things to do. We can do a lot of things to bring nephrology and, of course, dialysis to a more sustainable and green environment. So I think we can do all together. Thank you very much.
Thank you.